Let's look at how to calculate the probability of A or B using both the addition rule and using contingency tables. And I'll start with contingency table. So here I have 50% of trail mixes have peanuts, 30% have raisins, and 25% have both peanuts and raisins. So when I'm making these tables, I put one of the variables as my columns. Columns like a building go up and down. And I'll put another variable as my rows going side to side. So I have things with peanuts and no peanuts, so peanuts complement. I have things with raisins and things without raisins. And on the outside of my table, I like to put two lines to remind myself that I should add everything up to get a total. And if I add everything up correctly, I should get 100% or 1.00 as an answer there in that corner. 50% in total have peanuts, so I'm going to put 0.50 or 50% here. 30% have raisins, so the total for the raisins is 30%. And any sort of combinations are going to go on the inside. So 25% have both peanuts and raisins. That's where these two things meet together. 0.25 lives there. And things should add up correctly vertically and horizontally. So 25% and 5 yields 30. 25 and 25 gives me 50. 50 and 50 gives me 100. 30 and 70 give me 100. 5 and 45 give me 50. And 25 and 45 gives me 70. I'm double checking my work. Now, I'm going to do this using this contingency table first. And when I'm using this table to find something like the probability that something has either peanuts or raisins, or possibly both, I'm going to look at my four inside boxes here. And I'm just going to put a little bit of a check next to anything that satisfies one of these two conditions. Or is sort of an inclusive or. And what I mean by that is or gives me more. Or gives me more options for things to look at. For example, these have peanuts and raisins. I was already sold. I like trail mixes that have peanuts in them. This has peanuts but no raisins. Great. That's also something I would enjoy. This does not have peanuts, but that's okay. There are other things that I like. I would also be happy with raisins, and this has raisins in it. This does not have peanuts, so that doesn't pass that first check. It doesn't have raisins either, so this looks like the only one out of these four options that I don't like. So I find all the values that work on the inside. And then I'm just going to add them up to find my probability. So in this case, I have 25% and 5% and 25%. I'm adding each of those checked things. This gives me 30. 30 plus 25 gives me a total of 55% of these trail mixes have either peanuts or raisins, possibly both. I like these visual ways of seeing it because if any of my numbers are wrong, I can adjust that pretty easily. But I also want to show you the addition rule. The addition rule says the probability of A or. And when you see this U going up, that means union, or that's read as or, A or B, is equal to the probability of A plus the probability of B minus the probability of A, and this symbol means intersection, it's where they meet, and B. Let me show you what this is using words. I'm looking at the probability of peanuts or raisins. So I can take the total of peanuts, and I'm going to circle these in the table just to show you how this rule is working here. So I could take the total of peanuts, that's everything in here that's giving me that 50%. It's those two numbers together. And I can add to this the total of raisins. So I'm going to add to this anything with raisins. And if I add these totals, this is going to be 50% plus 30%. I'm at 80%, and that looks like it's too big. And the reason why it's too big is I'm noticing that I've accidentally counted this thing twice here. It's part of this vertical circle, and it's part of this horizontal circle. So I need to subtract where they overlap. So minus the spot with peanuts and raisins. Now, I can use the table to come up with this. I can also look at the paragraph to find these numbers. Let's go ahead and use the paragraph. 50% have peanuts, so 0.50. 30% have raisins, 0.30. And it's really tempting just to add those two numbers and call that a day, but I can see in my picture above here, I'd be making a mistake. I'm overcounting this spot. So I need to subtract raisins and peanuts here, 25%. And when I do this, I have 80% minus 25%. That gives me 55%. So these are similar but different methods in that when I'm using the contingency tables, I intentionally only include each value once. But when I'm using this addition subtraction rule, I'm just sort of adding things up willy-nilly, and then I'm fixing mistakes as they come along. So I sort of intentionally overcount and then go, oh shoot, that's too big. I have to subtract anything that I've circled more than once. If you find this to be the easier method though, I would encourage you to use it. I want you to do whatever you can to find these probabilities.